Hello, everyone. We will be presenting on the Nashville Vision Zero initiative and supplementary technologies to this initiative.
So I'm Tyler Flanagan. I served as the group leader, 22 years old, and I'm a civil engineering major.
Zach Wilson. I'm in charge of the group organization. I'm 23 and also a civil engineering major.
I'm Preston Gibbons. I was the administrative officer. I'm 21 years old and I'm a civil engineering major.
My name is Salman Abu Mazin, and I'm the group researcher analysis. I'm 26 years old, majoring in electrical engineering.
So we're working on the Nashville Vision Zero project for the Transportation Technology Tournament. There's been an increase in pedestrian hit and run collisions in the city of Nashville. Right now, there's about an average of 84 incidents a year. And so we're using different technology and education to come up with an innovative solution to address these collisions.
So a little bit of background on the topic. Nashville nationally ranks 24th in traffic deaths. There have been 468 deaths since 2014. And only 3% of residents say that they walk as a primary form of transportation. However, 17% of all traffic deaths are pedestrians. So the Nashville Vision Zero initiative is here to address that issue. It was a study focused on identifying areas that are in need of attention, and it aims to impose changes to current infrastructure, public transit, and design specifications of those problem areas. However, our group feels that it does not adequately assess the use of technologies available that can be used to mitigate the issue, and that is what we are presenting on today.
Okay, so to kind of analyze the problem and come up with innovative solutions, we researched both technologies and methods to implement in Nashville to reduce hit and run incidences. The first being pedestrian scale lighting. This is intended to create an environment at nighttime where drivers can quickly and accurately identify pedestrians on sidewalks and crossways. There's two styles, the first being LED light poles, and as you can see on the left upper picture, that's the light poles, and the bottom left picture is LED crosswalk strips. These are generally installed in or near sidewalks with high occurrences of nighttime incidences, and crosswalks where there aren't the typical signals or hawk systems implemented, also in typical low light areas where high usage city roadways are placed. To analyze the first of those, the LED light poles, a study by Frank Markwitz indicated that about 2/3 of the pedestrian fatalities in the U.S. occur at night or during low light conditions. Therefore, it would be beneficial to put pedestrian scale fixtures up. These are to improve the visibility of pedestrians as they walk across or on sidewalks. They're generally directed straight towards the sidewalks. They're positioned lower than the typical light fixture on roadways at 12 to 16 feet, and they're spaced closer at only 60 feet in between each light fixture. This gives an ability to light both sidewalks and crosswalks fully. The only limitations with this are obviously it'll only be beneficial in low light hours, and the surrounding infrastructure may need additional development to keep up with the capacity of entry that'll be needed. And the cost to install one light fixture is around $4,882 a piece. The second solution, again, being the LED light strips. A research article done by Sierra Patella indicated that a car's mean average speed decreases by 19.3% when they approach a crosswalk that's illuminated with these light strips. They're used to enhance the ability for drivers to identify pedestrians as they walk across these crosswalks. They're generally installed directly into the crosswalk pavement and positioned to shine directly on the pedestrian. As you can see on the picture on the top left, without the lights, it's kind of just a dark figure walking across the crosswalk. And when the lights are installed, you can vividly see a pedestrian as they walk across. Again, these are only beneficial during low light hours, and it doesn't protect pedestrians against their own neglect from walking across the streets without paying attention to the area. They generally cost around $2,500 a piece, though.
So another solution is the Hawk Crossway system. These were developed by the city of Tucson, Arizona, and they're best to be used at pedestrian crossings that don't have a traffic signal in place. The goal of these is to allow pedestrians to cross major streets while limiting the impact on traffic as much as possible. And this slide will kind of go into how this works. So the Hawk looks similar to a traffic signal, except the lights begin dark whenever there's no pedestrians there. As soon as a pedestrian wants to cross the street, they'll press a button and this will activate a flashing yellow signal. This will allow drivers to know that somebody's trying to cross the street. It'll then go to a solid yellow and a solid red. At the solid red, the drivers should be stopped and the pedestrians are free to cross the intersection. After a certain amount of time, this switches over to a flashing red. So the drivers can approach the intersection, and if they see that the pedestrians have already crossed their lane of traffic, they're free to continue. And eventually the light will return back to dark and drivers can drive through like normal. And so studies show that there's been a 70% reduction in pedestrian collisions and a 30% reduction in total crashes where the system's used. And each one of these are $100,000. So depending on the resources that are available, they can be built around the city wherever pedestrian crossings are needed.
Another technology that can help solve this problem is connected vehicle technology. This is an intermodal data collection and communication technology that can be installed in vehicles or infrastructure. And it provides an immense amount of data that a vehicle can use to automatically assess risk and mitigate collisions. And there are three different types of connected vehicle technology. And the first is vehicle to vehicle, vehicle to infrastructure, and vehicle to pedestrian. So as a whole, connected vehicles estimate, it is estimated that they can prevent 80% of all vehicle incidents. And they do this by using LiDAR or radar sensors that can detect, classify, and communicate data to vehicles or pedestrians. And it improves the ability for a driver or a vehicle to react in a timely manner by outsourcing the data collection part of detecting objects in the roadway. And in turn, it enhances onboard vehicle safety features such as lane assist or collision detection and automatic braking. So there are a few stakeholders when it comes to connected vehicles. The first is the obvious one, which is transportation departments. And they're really concerned about the operation, management, and oversight of the systems themselves. And secondly, we have the user, which is broken down into motorists and pedestrians. And they want this technology to be easy to use. They want it to be effective to where they feel that it serves to protect them. And the last is the automotive manufacturers. Obviously, they're the ones creating the cars. So they need to, or they care about the standardization of systems that collect data and communicate data. So this technology can be used in wherever the vehicle ends up. When it comes to cost, this is a relatively inexpensive solution. On average, it costs about $17,600 to install in an intersection or a problem area where it is deemed that these sensors need to be placed. So this is a very viable solution to our issue.
And from the safety consideration, I'll talk about 2 points. The first one, transit stops and sidewalk. First, the location and design of transit stop can significantly impact the safety for the pedestrian. For example, buses should stop where pedestrians frequently transfer between different buses routes, and it should be located on the same side of intersection. They can make transit location. They can make transit locations, make an organizational change. They can have long-term positive effect on pedestrian safety. They will encourage pedestrians to cross the roadway from the intersection way. Second, we have the sidewalk. As we can see in the picture, the sidewalk is not wide enough for all three children to walk side by side. The sidewalk should be wide enough to accommodate the expected walking traffic. Narrowing sidewalk that cannot keep up with pedestrian traffic, tempt pedestrian to walk in lanes or take different routes, increasing the likelihood of a car collision. It is desirable to provide a wide sidewalk. Next slide.
Okay, and in implementing these solutions, we came up with an enterprise architecture breakdown. This included 4 subcategories being business architecture, data architecture, technology architecture, and application architecture. These kind of just highlight the key components of developing each solution into the actual roadway system and transportation. And these are our sources. Are there any questions?